guys. I'm Matthew Thomas, and this talk is going to be about health checks in .NET. Can everybody see my screen here just to confirm
Yep.
before we go? Okay, great. Um, so this talk is going to be about health checks in .NET. This is something that Microsoft introduced in .NET Core 2.2 all the way back in 2018. So there's a high likelihood that this tool will already be in your tool belt. It can be a bit of a dry subject, but it's something that saved me and my projects on numerous occasions. It's a really simple concept and it's super easy to implement. With just a little bit of effort, you can get huge benefits. And today I'm going to show you how to do it. To kick it off, we're going to take a second to define health checks. It's both a concept and a technical term, and we're going to take a second to get some definitions out of the way so that everybody's on the same page. We'll then look at implementing health checks, building health reports, and ways that you can get rich data out of that health report. Manually monitoring these reports kind of sucks. So we'll briefly talk about some options for monitoring, as well as how we use these health checks at the credit union. And then I'll wrap it up by showing you something that you won't find in the documentation. And I'm sure there'll be time so we can do a little Q&A at the end. But first, who am I? As I said before, my name is Matthew Thomas, and for the last 7.5 years, I've worked at Security Service as a DevOps SME and a .NET developer. I created and maintain our build and deployment pipelines in Azure DevOps. I've led modernization efforts for several high-traffic web services, and I'm the primary developer of the online services which allow us to offer Zelle to the membership. And so don't quote me on this, but I think the public-facing bits will be out closer to the end of the year. In my personal life, I have 2 daughters, and I enjoy scuba diving. Due to the drought, I don't get to go as often as I'd like, but this weekend I'm going to the Valhalla missile silo in Abilene. It is something I really enjoy doing, and I think everybody should try it at least once. So I mentioned that health checks are both a concept and a technical term. So let's talk about it as a concept first. When we're developing web applications, health checks allow you to inquire about the status of your application. They help ensure that your services are not just running, but they're running well. So let's take a look at the weather API. We've developed it, we've pushed it to production, the Swagger page comes up, and so everything's good. Time to go home, right? Well, maybe. Uh, the trained eye will see that this service has, at a minimum, 2 extra dependencies that we are not sure are functional. And the first one should be pretty obvious. It's the weather service that we're fronting. I mean, we are not the authority for weather forecasts. Another service is. We just query that thing, we add some value, and then we return a response. And so then a couple questions pop out of that. First and foremost, did the network people open a port so that our server can talk to their service? I mean, we can do everything right in code, but if we're getting blocked at the network level, we don't have a product. And assuming that we can communicate with them, they require us to present some credentials. And so are those credentials good? I mean, nobody ever fat fingers an API key, right? Right? Uh, and so assuming that everything's good, uh, are they honoring their SLA? I mean, they said that they were going to return responses in under 200 milliseconds. So are they doing that, or is every request to them timing out? The other dependency that we're taking on is less obvious, but it's equally important, and that's our authentication service. If we are requiring users of our service to authenticate, and we can't verify their excuse me, if we can't verify their presented credentials, gosh, I can't talk today. That's a problem. And so health checks, the concept, attempts to answer the question, for every dependency in this application, can we actually use it? And so that leads us to health checks, the technical term. A health check, as it pertains to .NET, is a class that checks the status of a single logical dependency. It implements iHealthCheck, and that interface has a single function, check health async. The function returns a task of health check result. And we'll expand upon this in a minute, but a health check result is either healthy, degraded, or unhealthy. And so it's up to you, the developer, to define the conditions that will yield a healthy, degraded, or unhealthy result. And that's all based on what normal looks like for the thing that you're checking. In practice, most things are either healthy or unhealthy. Degraded is usually reserved for when a dependency exceeds its SLA. A good example is when we have a database query and it executes successfully, but it just takes longer than expected to return. And so a collection of health check results makes up a health check report. And in addition to capturing the result of the check health async function, Microsoft also captures how long it took for that function to execute. So we, as health check implementers, don't have to put timing values in our reports. It's done for us. Microsoft uses those results to then build a health report object. The status of this report is the worst result in the collection. And that can suck because if you have one unhealthy thing and everything else in the report is healthy, the entire report is unhealthy. So let's take a look at what a health check implementation looks like. This is a health check that we at Security Service include in every application. It makes sure that we can resolve the name and version of the entry assembly. And so I know what you're thinking. That's kind of an odd thing to check. But what it does for us is it ensures that the name and version of the application are included in the health report. And I'll expand on this in a little bit, but we do health checks at deployment time. And this is a real easy way to sanity check that the service account is properly configured on the box and it's allowed to run the application. Independent of that, health reports must contain at least one check in them. And this is a real easy way to give developers a freebie. You'll notice that this check does not have a constructor, and that's purely coincidental. These checks are going to be registered with the dependency injection container. So if you need other services or configuration from your application to implement your check, just resolve those services through the constructor like you would any other type in your application, and then use them to build your response in the check health async function. As you might expect, there's already implementations out there for common dependencies. Microsoft put one out there for Entity Framework Core. And there's a GitHub organization called Xabril, Xabil, and I'm sure I mispronounced that for somebody. But they went and implemented checks for a lot of the big services that people use. A bunch of Azure stuff, Amazon, DynamoDB, IBM MQ, Kubernetes, Hangfire, RabbitMQ, Redis, and a bunch of others. And so with an implementation of a check, that's really just step one. We still have to register the checks with the dependency injection container. And so what we'll do is we'll call services.add health checks. Add health checks returns a builder, and on that builder, you'll add your check. Now, checks need a name and a collection of tags. And the name must be unique across all registered checks, and ideally, it does not contain spaces. Now that our checks have been added, it's time to advertise them. Rather than being a special kind of controller, Microsoft implemented the handler for health checks as middleware. There's a few performance reasons for it, but ignoring that, having it as middleware allows you to opt out of the auto-generated open API spec you advertise to your consumers. They leave it to you to define the route and how healthy, degraded, and unhealthy map to status codes. The recommendation is for healthy and degraded to return a 200 and for unhealthy to return a 503. But if you want it to be something else, it can be whatever you want it to be. These statuses map to an int. So if you want to return a 418, by all means, off you go. And so when we run our application and issue an HTTP GET against our health endpoint, what we get is the overall status of our health report. And so, this is great, but what if we want to see how this breaks down check by check? Well, we just come back to our endpoint registration. In addition to status code mapping, Microsoft gives us a delegate for writing the response body. That delegate gives us the full report and access to the HTTP context. So, however you want to respond, the sky is really the limit here. For us at the credit union, we just serialize the full health report. And so you'll see that with the custom response writer, our application is still healthy, but we get a much better breakdown of why it's healthy. And with this knowledge in place, we can start to do some cool stuff with it. But there's one other thing that I want to show, and that's the concept of heartbeats. With what we have right now, every time we execute a health check, we're executing every registered check. And that's fine, but if you hit it too often, you're going to start introducing artificial load on your downstream resources. You can imagine that if you gave what we have right now to some network guy, they'd configure it to ping every 500 milliseconds, and then the database people would start yelling at you, and all of a sudden you got a mess on your hands. Additionally, if you're hitting internal services and they advertise the same health check logic, a health check request on a top level service can easily have this unintended domino effect if you're not careful. And so that's why at the credit union, in addition to advertising a full health report at a health endpoint, we utilize the same infrastructure to run a single check at a heartbeat endpoint. Health check options give you a predicate that lets you run only a subset of all the registered checks. And in our case, when we execute a heartbeat check, we only want that name version check that we discussed earlier. And so if you're developing like we do, any check that you write should reach out to the heartbeat endpoint of a downstream service, not the health endpoint. This allows you to determine the availability of the service without triggering a spider web of requests. You can also give that endpoint to your load balancer guys, and they can route traffic based on your response times. And so with all of that in place, this is a good spot to talk about monitoring. Now, originally, when I was putting this presentation together, I was going to walk you through writing a URL ping test in Azure. But I did a little research and I found out that they're going to be shutting this feature down next year. And so I don't want to show you how to do something and then you go and build stuff on top of it and then it to be taken away shortly after you build it. If you want to go out and do it right now anyway, it is still available. So there's that. But do you remember that GitHub organization that we talked about earlier, Zabrel? Well, they have a health checks UI project that you can self-host. In the project's configuration, you give it a collection of URLs, and then at an interval you specify, they'll execute that URL. Results are stored in the database so you can see history. And if you configure the webhooks, there's an option to get notified by Microsoft Teams, Slack, or an Azure function whenever it detects a failure response. They also have a Docker image for this thing if you want to run it that way. And so I'll just say there's one problem with these two solutions. The URL that you give them is almost always behind a load balancer of some kind. And this really isn't a problem if you only have one instance behind your load balancer. But the whole point of a load balancer is to have multiple instances. Uh, and so, what do you do with that, right? Well, you can do something with the host header, or you can put a custom routing rule that allows you to target a specific box if you match a certain pattern. Um, all of these choices still have the same problem. You're introducing artificial load on your service when you don't need to. And so that's where health check publishers come into play. When you register this with the dependency injection, every 30 seconds, a background worker will run. It will generate a full health report. It will instantiate your publisher, and then it will call the publish async method on that publisher. From there, it's on you to send it wherever you see fit, however you see fit. The 30 seconds is configurable, and like with the endpoints, there's a predicate so that you have the option of running just a subset of the registered checks. At the credit union, we implemented a logging health check publisher. And by sending the reports through the logging system, we flex all of our existing infrastructure that's in place for normal application logging. And because of that, we get alerting and historical analysis for free. So all of this stuff is super cool, right? I mean, there's not a lot of effort on your part to get all of this value out with this framework. Um, but there's really something interesting about all of this. All of this stuff is defined in the Microsoft Extensions Diagnostics Health Check package. And if you open it up and look at its dependency graph, you'll notice there's something missing. And that's anything related to ASP.NET. And the cool thing about that is that it means we can use it in our console apps and our Windows services. Windows services are just long running tasks, just like web applications, so they can make use of the health check publisher just like web APIs can. Console apps are a one and done kind of thing, but we can use them to verify connectivity to our downstream resources. All you have to do is just look for an argument flag before you run your application. If you get that flag, resolve the health check service, get a health report, dump it out to the console, and exit. Here at the credit union, every single application that we write on our team supports this feature: APIs, Windows services, and console apps. Because of that, our deployment pipeline can execute a health check on the prospective version of the code on the box while the prior version is running. Remember, in .NET Core, everything is a console app, including web applications. If the health check fails, we just abort the deployment, and the end users are none the wiser. But if it passes, we have a much higher level of confidence that the new version is going to function as intended, and we can proceed with the deployment. And so I'll leave you with some links to check out. There's a lot to read in the official documentation and even more in the Zabrel project on GitHub. I know it's a little old, but check out the original announcement post for .NET Core 2.2. All of the concepts that are in there are still relevant today. And I know we're living in the age of AI where you can just ask a question and get a direct answer, but Stack Overflow, the developer blogs, YouTube, and a good old Google search are still your friend. And so with that, I'll end it here. I know this was a bit shorter than the hour we've been allocated, but like I stated at the beginning, this is a pretty easy concept to implement, and it's a pretty big value add for your application and for your teams. So with that, I'll open it up to questions and see what we got to hear.
Yeah, I'm curious. You have you set this, I think this is cool. So you set up the health check in point, you have all that stuff. Do you use that as part of like the deployment pipeline or anything? Do you get notifications when things aren't healthy? Just like do you hook anything up to that? How you use it?
We typically rely on the health check publisher to alert us if something's going wrong, um, rather than the endpoint itself. Um, we'll use the endpoint usually whenever we get some kind of alert from the business. Um, if the database is slow, or if we have one that governs a whole background worker infrastructure that we host inside the app pool. Um, and depending on what it is processing or how fast it's processing, it can return degraded or unhealthy. And we'll use that for, I'll say, kind of a one-off check. But for periodic checks, we rely on that health check publisher, which is, I think, here. Yeah.
Okay. Yeah, I just was thinking, I think a lot of times when people have certain types of tests in their pipeline, you have these end-to-end tests or integration tests that like reach out
Mhm.
to all the services. So if one of them goes down, then your service can't deploy. I think really a lot of times what people actually want is a health check like this. And like you get these periodically, or you can, I guess, they can run on the hour or something. Like that way you get that more often than just whenever you deploy for one. Number two, you don't have to worry about like breaking your build as another service goes down. But yeah, I think health checks are myself included, a kind of neglected thing in the distributed world. I
Yeah.
saw your
Oh, go
chat
ahead.
also. You,
Go ahead.
I'm done. You have a question in the chat,
Oh, okay. Um, let's see. How do I see the chat?
or I can read it out. Be good for the recording
Oh,
too.
there we go. Yeah.
So Stephen Fuqua says, "What are your thoughts on security implications? For example, having detailed information in the slash health response can be great from a diagnostic perspective, but might reveal too much information to a potential attacker."
Yep. Absolutely. And that's where you work with your network people to ensure that your health and heartbeat and any they call them liveliness probes and readiness probes are not available to the outside world, or just outside your intended audience. Yeah, this is a strictly for internal use only thing.
I guess that is kind of like, do you need to be authenticated to hit the slash health endpoint? Seems kind of
Um,
overkill, maybe.
by default, no. But it's middleware that hooks into the request pipeline. So if you want to throw authentication around it, absolutely you can.
You got another one in chat here. Does the report have to be a full listing? Can you segment or have partial reports?
Um, so no, it does not have to be a full listing. For two reasons. Let's see. Uh, that one there, I think, or was it? Where we talk about the predicate? Yeah. Okay. So for two reasons, this this endpoint that you define, you can as long as it doesn't collide with your application, there's no limit to the number of applications or the number of endpoints that you have that do health checks. Um, when you register them, you're going to give them a name and a set of tags. And so you could have one that just does database checks, and you could have another one that just does RabbitMQ checks, and another one that does just me checks, and another one that does permission checks. And the sky's the limit on that. There, anything that is returned true on this predicate function is going to get included or flexed on the execution of this endpoint. And so that's one way that you can do that. The other way is whenever you have the response writer, uh, whatever report is built, you have full access to it. So if you want to pick it apart and pull certain bits out of it, tags, rename stuff, if you want to modify the overall status of the report that goes out the door, like you're doing a raw string write to the caller here. So that's your chance to modify it or to trim it down as you see fit there too.
That makes me think of something else too, that I guess, like, obviously I think this is kind of an art, right, of how much to include in a check, right? Like, of course, this isn't testing your endpoints, right? So do you test every single endpoint you have? Like, how granular should you get with it? I guess it's like, what level are you comfortable with? How often does it happen? I don't know if you found there's like an answer to that, or if it's just kind of,
It
I
is.
know
It's
some
one of
people
those more of an
confident,
art than a
no big
science
deal.
kind of
Like,
things.
yeah,
Uh, in general, we assume that our code functions as intended. That if the app pool is alive and we are executing our code, then at our level we are good. And so these checks are to verify connectivity for the next step down. If I've got a database, if I've got RabbitMQ, if I've got a Redis cache, if I touch the file system, because some things will dump either a log or they'll dump to a network share for like a job queue. Uh, you know, it, every app is different, and it's up to you, the developer, to make that decision as to what you care about.
is good timing. Someone else has some chat as a reference example. How many endpoints are being checked in your company?
Every single what do you mean like application endpoint or this is a feature that we bake into every application. So every deployable has this feature.
It sounds like you create an extra endpoint for the health check. You don't test individual endpoints one by one, like that you actually
Correct.
use in production, right? Yeah, okay.
Correct. So as a project, we inject two endpoints for the application, the health and the heartbeat endpoint, and then it's on the developer um, to in, well, it's always on the developer, but we have an internal framework that automatically bakes these two in, and then it's on the developer of that individual application to add additional ones if they so choose. Um, I think there's maybe one out of the 200 some odd applications that actually do bake in a third endpoint that utilizes this infrastructure. So um, I don't know if that answers the question or not.
It makes me think,
Uh,
I guess
yes,
you
Matthew,
probably
thank
want
you.
enough info. Oh, sorry.
Yeah, well, I'm just figuring out how it is, well, interlaced, but yeah, it's good, the answer.
It sounds like you probably want enough info to know if it's your team's responsibility, like when this thing breaks, or if it's this other team down the line. So,
Yeah, whose neck
There's
are
like
you going to wring,
comments.
right?
Right. Yeah. Who's coming in on the weekend? There's a comment in chat. It says we use the tags to segment health checks into logical groups. For example, some health checks are specific to K8's startup probes, while others are used for K8's readiness probes. We use tags to categorize. That's interesting. I don't know if you had tags in the demo there. I can't remember.
Yes, I think we did on, yeah, here it is.
And then another question. I didn't quite understand the difference between health and heartbeat endpoints. Why both?
Okay. That's actually a good question. So in this example, I've just added one check to the overall set of available checks. But in a real application, in addition to the name version check, I'd have a database check, I'd have a third-party check, I might have a check that connects to my authentication service. And so whenever I execute the health endpoint, those four things all need to be flexed. But whenever I execute the heartbeat endpoint, I don't care about that stuff. I just care about, am I alive? Yes or no? And so the heartbeat one is just for the quick 200 OK, and I don't care for me, and I don't care about all the other stuff that I talk to.
And I think the reason you had both of those is because health can like trigger a bunch of things downstream. Is that
Yes, yeah.
like you might trigger their health?
So
I don't know.
yeah, so health will trigger a bunch of stuff downstream, and maybe that's the intention. I don't know, right? I mean, it's your application, but for a heartbeat scenario, um, we just, or I'm sorry, yeah, for a health scenario, we just want to know the can I reach the next tier down? Um, I just care about let's go back. Yeah. So for a health scenario, I just care about this hop here. I do not care about this hop or this hop. And so having a heartbeat endpoint on this guy allows me to make that hop and not trigger the second or third level hop. Does that make sense?
Yeah, it does to me.
Yeah. In the chat there, it says heartbeat is basically a ping. That's absolutely correct.
Like in our AWS setup, if one of the lightweight, AWS calls them health checks, but what's basically a heartbeat, if it did not return successfully, AWS would start destroying instances and spinning up new ones. And I would like you to please not do that if the weather service is down. So there's another place where you'd want those two different tiers of information feedback.
Yeah, I think AWS calls them like canary checks or something, doesn't it? Like if it fails to ping something, your CloudWatch alarms go off and all of a sudden it starts doing all whatever rules you set up.
We do have, yeah, canary checks for just like the built-in, it's just called health check for does that instance need to be replaced, restarted, that task that can
Sure.
yeah.
All right. Looks like I think we got through everything in the chat. So I think we're good. So I'll give everybody about 20 minutes or so back. So thanks, Matthew, for presentation. Thanks, everyone, for questions and thoughts. And hopefully next time we meet, be a little cooler. And yeah, as always, reach out to Ashish and I for interest in speaking. And please fill out the feedback form for this month for Matthew. Yeah, and good luck, Matthew, in scuba diving in your missile silo.
Oh, yeah. Thank you.